Welcome to the deep dive. This is where we take your source material, really get into it, and pull out the key insights for you.
Exactly. We help you cut through the noise and focus on what's really essential in the documents you've provided.
And today, wow, we're diving into something pretty profound. It touches on that age-old question: what happens to consciousness after death? You've brought us this theoretical paper, and it looks at this through the lens of quantum physics, which sounds intense.
It definitely is. Yeah, traditionally, this is philosophy, maybe religion, but this paper tries a scientific angle using quantum mechanics concepts.
Right.
But we absolutely have to stress, and the paper does too, this is speculation, it's theory, it's not like, here's the proof. We're exploring some fascinating what-if ideas based on physics that's already pretty weird.
Quantum mechanics, yeah. Famously counterintuitive. So the idea is maybe some of that quantum strangeness offers a way to even think about consciousness persisting, even if we can't prove it yet.
Precisely. And to even start that conversation, the paper first acknowledges how tricky consciousness itself is to explain scientifically.
Okay, right. So let's unpack that first. The paper mentions David Chalmers, the philosopher, and the hard problem of consciousness. Why start there?
Well, the hard problem, it's the question of how subjective experience, the actual feeling of seeing red or tasting something, that inner what it's like, how does that arise from just physical stuff, neurons firing in the brain?
Oh, okay. So neuroscience can show us what the brain does, the mechanics.
Yeah, it maps the correlates.
Yeah.
But why does all that physical activity feel like anything at all from the inside? That subjective quality, the qualia, that's the mystery.
So even with amazing brain science, there's still this gap. Objective brain activity to subjective feeling.
That's the core of it.
Yeah.
And the paper sort of leverages that gap. It says, look, if classical physics and standard neuroscience can't quite bridge that divide fully, then maybe, just maybe, it opens the door for explanations outside the classical box, like quantum ones.
Gotcha. So one of the first big ideas the paper brings in is from quantum information theory. That information itself might be fundamental, not just matter.
Yeah, this is a really interesting shift. Instead of seeing physical stuff as the bottom layer of reality.
Right.
Some views in quantum info theory propose that information, the patterns, the relationships, the bits, might be even more fundamental.
And connected to that is the idea of information conservation, like energy.
Sort of analogous, yeah. The principle is that the total information in a closed system doesn't just disappear. It can change form, move around, get scrambled, but it's conserved.
Okay.
And the paper mentions John Wheeler's famous phrase, it from bit. The idea that everything physical, every it, gets its existence from information, from bit.
Okay, it from bit. So reality is informational at its core, and information doesn't get destroyed.
Yeah.
How does consciousness fit in there for survival?
Right. This is where the speculation really ramps up. If you start thinking, well, maybe consciousness isn't just something that pops out of a complex brain. What if consciousness itself is fundamentally an informational pattern? Then that principle of information conservation starts to look relevant.
So if the brain, the physical hardware, dissolves.
Maybe the conscious information, the pattern, doesn't get annihilated.
Yeah.
Maybe it persists somehow.
Yeah.
Transforms, redistributes.
Yeah.
Because the underlying information is conserved.
So the core idea, consciousness, information, and information survives.
Yeah.
Okay. Then the paper looks at specific quantum effects as possible mechanisms for how this might actually happen. First one, quantum entanglement, the spooky action.
Right, entanglement. You link two particles, and measuring one instantly tells you something about the other, no matter how far apart. They're correlated in this deep, non-local way.
Spooky indeed. So the leap here is consciousness gets entangled.
That's the speculative proposal. Maybe parts of our conscious experience become entangled, not just within the brain, but maybe with other systems, other conscious entities, or even just the background quantum fields of the universe.
So if that entanglement exists,
then even if your physical body dies, the correlation, the link, might persist. Your consciousness wouldn't be localized anymore, but aspects of it, the information, could survive in this distributed, entangled network.
So entanglement suggests survival not as a single ghost, but maybe as a dispersed pattern held in these quantum links.
That's the gist of the speculative idea, yeah. Survival via distributed correlations.
Okay, different angle now. Quantum field theory, how does that fit in?
QFT sees the universe differently. Not particles in empty space, but fundamental fields everywhere, like an electron field, a photon field. Particles are just excitations, like ripples or vibrations in these underlying fields.
So an electron is a blip in the electron field. Could consciousness be a blip in some kind of consciousness field?
That's the analogy the paper explores. Highly speculative, of course. But what if consciousness emerges from activity in some fundamental quantum field? Your individual consciousness is like a temporary, localized ripple in that field.
In death.
Death wouldn't be annihilation, but maybe the ripple just subsides. It returns to the field's baseline state, the ground state. The field itself is eternal, always holding the potential for new ripples, new consciousness.
So the QFT idea, consciousness is a temporary pattern in an eternal field. Death is the pattern dissolving, but the field remains.
You've got it. The potential persists because the field itself is conserved.
All right, buckle up. The many worlds interpretation, MWI. This one feels like sci-fi.
It does stretch the mind. MWI is one way to think about quantum measurements. Instead of a particle choosing one state when measured, MWI says all possibilities happen. The universe constantly branches, creating parallel realities for each possible outcome.
Every quantum coin flip creates a new universe. That's a lot of universe.
An incomprehensible number, yeah. But this leads to the idea of quantum immortality. Super speculative, but the thought is,
Go on.
Your stream of consciousness is tied to these quantum events. So you would only ever subjectively experience the branches where you continue to survive. You might die in countless branches.
But my awareness just keeps flowing along the path where I didn't die.
That's the bizarre logic of quantum immortality based on MWI. You always find yourself on a surviving timeline from your perspective.
Wow, okay. So the MWI takeaway is survival by always subjectively ending up in a universe branch where you're still alive.
That's the core premise. And the paper even mentions an even wilder extension, quantum archaeological resurrection.
Oh boy.
If consciousness is information stored in quantum fields, maybe, theoretically, some super advanced future civilization could retrieve that information and reconstruct past conscious states.
Like rebuilding minds from cosmic data.
Basically, yeah, pure sci-fi territory. But it follows from the idea of information persisting in those fields.
Okay, let's reel it back a tiny bit. Still speculative, but closer to the brain. Workshop. Orchestrated Objective Reduction. Penrose and Hameroff.
Right. This one points to specific structures inside neurons. Microtubules.
Penrose,
the physicist, and Hameroff, the anesthesiologist, propose that consciousness isn't just classical neuron firing. They argue it involves quantum processes happening within these microtubules, specifically something called objective reduction, a self-collapse of quantum states.
Quantum states like superposition, being multiple things at once.
Exactly. The idea is microtubules can maintain these delicate quantum superposition states, and consciousness emerges or is related to the moment these states collapse or reduce into a definite state, influenced by gravity at the Planck scale. It's complex.
Very. So how does that microtubule quantum dance relate to surviving death?
Hameroff speculates that when the body dies, the quantum information processed in the microtubules isn't necessarily lost. It might decohere from the brain structure, but the information itself could persist at a more fundamental level, maybe embedded in the very fabric of space-time geometry at the Planck scale, surviving the brain's breakdown.
And that connects to the quantum soul idea mentioned.
Yeah, it's related. The hypothesis is that your unique conscious pattern, your quantum soul, isn't just in the brain, but maybe encoded in space-time itself via these quantum processes. When the body goes, this pattern might persist independently.
Okay, so the Orch-OR related idea. Consciousness is linked to quantum stuff in brain microtubules, and that quantum information might stick around even after death, maybe in space-time itself.
That's the essence of it, yeah.
All right, next on the list, quantum tunneling and parallel dimensions.
Quantum tunneling, another classic quantum effect. A particle can basically pass through a barrier it shouldn't have enough energy to get over, like rolling a ball at a hill and it just appears on the other side sometimes.
Weird. So apply that to consciousness. Death is the barrier it tunnels through.
That's the metaphor, the speculative leap. Maybe consciousness isn't stopped by death, but it can somehow tunnel through that barrier.
Tunnel.
Well, that's the big question. Maybe it emerges in a different state of being. Or, even more speculatively, maybe it tunnels into a different dimensional space, one with different rules where it could persist non-physically.
Leading to that idea of jumping to a parallel dimension at death.
Exactly. If other dimensions exist, and if consciousness can tunnel, Maybe death is the trigger for a transition into one of those dimensions.
So tunneling suggests survival by passing through death into another reality or state.
A highly speculative dimensional persistence idea.
Okay, last major theme from the paper. Consciousness not just as a product of reality, but maybe as a fundamental observer that helps create it.
Yeah, this goes back to the quantum measurement problem. Why does a quantum system choose a state only when observed? Some interpretations, like from Stapp or Goswami, give consciousness a key role. They suggest the act of conscious observation is what actually causes the quantum wave function to collapse.
Whoa. So we're not just watching the movie, we're somehow projecting it by watching.
It's a radical perspective shift, definitely. If consciousness is required for the universe to go from fuzzy quantum possibilities to definite reality, then maybe consciousness is more fundamental than the matter it observes.
And if it's that fundamental?
It couldn't just be switched off when the body dies. Its role as the observer might need to continue, perhaps in some non-physical form.
This sounds like John Wheeler's participatory universe idea again.
Exactly. Wheeler argued observers aren't passive. We participate in creating reality through measurement. If consciousness is essential for reality to be reality, maybe you can't eliminate it. It might transform or merge, but its fundamental role persists.
So the core thought, consciousness survives because it's necessary for reality itself. It has to keep observing.
That's the mind-bending possibility these observer-centric views raise.
Okay. We have covered some seriously out there theoretical territory, all based on your source material. But importantly, the paper itself stresses these ideas face huge scientific challenges, right?
Absolutely crucial. It's vital to understand these are not accepted science for survival. They are fascinating theoretical explorations,
But they run into problems. What are the main ones?
a really big one is scale and something called decoherence. Quantum effects like superposition or entanglement are incredibly fragile. They usually only happen reliably at tiny scales, super cold temperatures in very isolated systems.
And the brain is not like that.
Not at all. It's warm, wet, complex, incredibly noisy from an environmental perspective. Quantum states tend to decohere, lose their quantum properties almost instantly in that kind of environment.
So the brain's just too hot and messy for these delicate quantum states to survive long enough to do anything meaningful for consciousness or store information reliably.
That's a major criticism, yeah.
Yeah.
Physicists like Max Tegmark have made strong arguments about this. It casts doubt on whether theories like Orch-OR are plausible or whether quantum information could really persist in the brain like that.
Okay, decoherence is one hurdle. What else?
Now, just basic testability. How would you even design an experiment to detect consciousness floating in a quantum field or tunneling to another dimension?
Right. It sounds impossible with current science.
It pretty much is. These ideas are largely unfalsifiable right now, which is a problem for scientific methodology. And then there's the whole emergence viewpoint.
Ah, the standard neuroscience view.
Exactly. The dominant picture is that consciousness emerges from the incredibly complex interplay of billions of classical neurons. Like how wetness emerges from H2O molecules, you don't find wetness in one molecule.
So consciousness is a property of the whole system working together.
Yes. And the idea that it could just float free, independent of that complex biological structure, really clashes with that emergent view. Quantum effects might play some subtle roles in the brain, sure, but are they enough to sustain consciousness without the neural network? That's a huge leap.
So, big challenges. Decoherence in the warm brain, lack of testability, and the conflict with the idea of consciousness emerging from complex classical brain activity.
Precisely. The paper presents these quantum ideas as thought experiments, as theoretical avenues, while fully acknowledging these major scientific roadblocks.
But even with those roadblocks, the paper does glance ahead. What if these ideas turned out to be right somehow? What are the implications?
Purely hypothetically, of course.
Yeah.
If consciousness is fundamentally quantum information, well, it opens up some wild possibilities. The paper touches on quantum computing.
Could quantum computers store or simulate a consciousness pattern?
That's the kind of sci-fi level potential being hinted at. Digital consciousness preservation, maybe even transfer, practical immortality via technology.
Wow, that's a lot.
Again, super speculative future stuff. But it shows where these ideas could lead. And beyond tech, the philosophical implications are massive.
Yeah.
How would this change our understanding of the soul, the afterlife, the intersection of science and spirituality? It could force a complete rethink.
And the ethical side, that must be huge too.
Immense. If consciousness can persist, what is identity? Is there responsibility after death? How do we define death or end-of-life care? If you could preserve consciousness technologically, who gets access? Is it ethical? What happens to the meaning of a natural life cycle? The questions are profound.
Okay, so wrapping up this deep dive, we've explored how your source paper uses quantum concepts. Information, entanglement, fields, many worlds, Orch-OR, tunneling, the observer effect.
That's theoretical tools, yeah.
Yeah.
Not as proof, but as frameworks to speculate how consciousness might survive death. Maybe as information, or correlations, or field patterns, or in other dimensions, or as a fundamental observer.
And it's a big but, we have to keep stressing these are highly speculative. They face major hurdles from physics like decoherence in the brain.
From neuroscience, like the emergent view of consciousness, and from basic scientific principles, like testability, they're not established science regarding survival.
Definitely not. But there are fascinating examples of how modern physics, with all its weirdness, lets us pose these ancient questions in new ways. They push our thinking.
Exactly. What is consciousness? What is reality made of? These quantum ideas provide a new language, new theoretical structures to grapple with those mysteries, even if the answers remain elusive.
So whether consciousness survives death, still one of the biggest unknowns. Maybe future work combining physics, neuroscience, philosophy will eventually give us clearer answers.
Maybe. But until then, maybe the value of these speculative theories isn't just in the answers they might provide, but in the sheer depth of the questions they force us to confront. What if reality truly is informational at its core? What does it mean if we as observers help shape it? That's definitely something to ponder.